chapters 2 and 3. And this is the first time that you're going to be actually analyzing data and working with StatCrunch. So let's talk about chapter 2, where we're displaying and describing categorical data. Remember, categorical data is data that puts the cases into groups. And we're going to talk about bar graphs and pie charts and frequency tables. So to make a frequency table, basically what you do is you pile up the data by counting the number of data values in each category of interest. And we can put these into a frequency table, and we can also put it into a relative frequency table. So here's an example of a relative frequency table. So we categorized a group of deaths by the cause of the death. And so 30.4% of the causes of death were classified as heart disease, 23.9% as cancer, and so forth. This is the relative frequency table. We could also have the counts here, and that would just be called a frequency table. So a bar graph is a nice way to display categorical data, and you put the categories across the x-axis, and then the height of each bar is either the frequency or the relative frequency that falls into that category. Notice here the bars do not touch. We can also do pie charts. That's the same data from the prior bar graph. And here we organize the data again into categories, and now each piece of the pie is the percent of the total. So another effective way to display the data. Okay, let's look at some charts with some problems. How about this chart here? What is misleading about this graph? So they're showing the sales for company A, and it's broken by quarter, so there's 4 quarters there. Now notice on this graph, the gold or yellow chunk and the blue chunk have the same percent. However, the way the graph is laid out, this is what we call a misleading graph. It's given us two-dimensional impression here. It's really hard. If the numbers weren't here, you might think that this gold area is larger. So the best answer of those given here, the angle makes it appear that the third quarter has a larger percent of the sales when in fact it's the same as the first quarter. We would prefer to see this as just a flat pie chart. It's much easier to read and interpret. So contingency table is a way to display 2 categorical variables and their relationship. So your cases are classified by each of the categorical variables, and we create this little table. So in this particular table here, we're looking at students that apply to a college, and we have admission decisions, either accepted, waitlisted, or turned away, and then we also have their race, ethnicity. So we can answer questions from the table. We see that 480 Black Hispanic students were accepted. The bottom row and also the side column here represent what are called marginal distributions. So this tells us of all the people in this table, if we collapse over ethnicity, 915 were accepted, 308 were waitlisted, and 521 were turned away. Okay, now let's use this table to answer some questions. Overall, what percent were accepted? So accepted 915 out of 1744. So about 53% were accepted. For the Black Hispanic students, now we're only using that row, what percent were accepted? So 480 out of 514, or about 93%. For the Asian students, now we're just looking at this row, what percent were accepted? 105 out of 291, or about 36%. And for the white students, 330 out of 939. Now, it's an interesting relationship here. If you notice, overall, about 53% of students were accepted. But when we further drill down into the race ethnicity categories, we see a great difference among the percent accepteds. And that leads us to say that these 2 variables are not independent. If they were independent, we would expect to see the same percent within each race ethnicity category. So we notice here that blacks were more likely to be accepted, and the Asians and the whites were less likely. Here's a little bar graph, and the graph shows the percent of owners of an electronic device that plan to purchase a replacement within the next 12 months based on, and you might want to, as you're reading a problem, kind of think about some of the information that you might be using, and perhaps we might want to keep track of that sample size, 1,100 randomly selected adults. What percent of game console owners plan to buy a new replacement in 12 months. So we look at the table and we look at game console and we see it's 10.6. If there are 250 million individuals who own a cell phone, how many are expected to replace their phone in the next 12 months? So for phone, it tells me 14.8%. So I'm going to find 14.8% of 250 million. And that comes out to be 37 million. The survey reported that 7.7% of digital camera owners expect to replace their device in the next 12 months. How would you describe the figure 7.7? So remember, this was calculated from the sample, so therefore we call this a statistic. Okay, here's a bar graph and a pie chart on the same information. They're looking at the genres of 117 first-run movies. Bar graph, pie chart. Which genre was most common? That's it. We could ask, what is the mode? Most common. So it looks like most common is the action adventure. Which graph is easier to read? Now for me, when the pieces of the pie or some of the bars are close in height or in percents, I always think the bar graph is easier to read. The blue and the green are pretty close, but the blue is a little tiny bit higher. So I would say that the bar graph is easier to read. Okay, for this one, I'm going to try to share the screen just to show you, I just wanted to show you on a problem here how you can pull up data directly from a homework problem and then use StatCrunch. So hopefully my screen share option will work, and we'll see if it does. If it does, okay, so I'm sharing the screen now. So I'm going to go over to this homework problem, and it's in Chapter 2, Problem 5. Chapter 2, Problem 5. And what I wanted to show you here is right to the right of this table, there's a little box there, and it says click to copy it. And you can actually copy to a clipboard, open in Excel, or open in StatCrunch. And then once it's opened in StatCrunch, you can answer the question here, and it's asking you to find relative frequencies. Here we go. Hopefully it will cooperate. Sometimes it doesn't cooperate with me. All right, I'm going to go back. I'm going to go back to what I just showed you was click here and you can open up that data in StatCrunch. And then what I did in StatCrunch is I want the percent for each group. So you could total these up and calculate the percent. You could also do that in Excel. But I did it another way. I did it with a pie chart with summary. So I selected the categories. They were in var 1, this column here. And then the counts were here. And then I hit compute. And then when I got my output and my bar graph, here's the percents right here. So it tells you the count within that category and the percentage. And so the answer for the problem wants 2 decimals. So we're actually going to have to recalculate. We need the total number of cars, which comes out to be 13,531. And then I can divide that into the 4515 and get the decimal. So sometimes the output here may not give you enough decimals, and you might want to recalculate. But all the others have 2 decimals, so you could just put those into the MyMathLab problem. All right, so I'm going to try another one. And again, I'm going to go and share my screen, and hopefully this one will work this time, so let's hope. MyMathLab, and you're going to go to StatCrunch, and you're going to click on StatCrunch, and then you want to do the data sets, the textbook data sets. And I'm going to go to Chapter 2, and I'm going to pick the twin bursts. And I want to create a contingency table with this data. And so I'm going to click on Stat. Oh, I'm not signed in. Okay. Oh. All right. Well, we're not going to do this today, so I'm going to come back over. It wasn't working there, but you're going to select Stat Tables Contingency with Data, select the level of care for the rows and the birth type for the columns. And here's what I get. I've just formed a little contingency table for this, and I've got here, these are the rows are the levels of prenatal care, and then the columns are the type of birth. So I've created a contingency table. What percent of mothers received inadequate prenatal care? Inadequate prenatal care. So I've got 63 out of 278, or about 23%. What percent were preterm? Preterm. Now, preterm, there's actually two categories. So I'm going to have to add those totals together, those two numbers, and divide by the total. So about 53%. This one plus this over the total. Among the mothers who received inadequate medical care, inadequate, what percent were preterm? So I'm only looking at this row, 63 moms, and preterm is going to be 12 plus 13, so 25 over 63, which is about 40%. Now, I'd also like to do a display that compares the outcome by the level of care. And there's a lot of ways to do this. I'm going to do it on StatCrunch graph bar plot with data, and I'm going to select the level of prenatal care, and I'm going to group by the birth type. And then I'm going to split the bars, and I'll show you what that looks like. And then also, let's get the percent within the category. So here's what the output looks like. So on my bar graph now, I'm grouping by the level of care, and then within that level of care, I've broken into the percents of the different types of births. So what do we see? We see that inadequate medical care leads to more term or post-term births. So if you notice here, this has the highest percent of the term or post-term births. Also, adequate and intensive prenatal leads to more induced or cesarean. Induced and cesarean is the blue, so those are higher in those two categories. Okay, another example. The table below gives the number of passenger car occupants killed in accidents in 2009 by the type of car. Convert this to a relative frequency table. So how do we do that? What we want to do is we need the total. So we're going to add up here and get the total number of occupants, and then we're going to divide each category count by the total to get the relative frequency table. And I just overlaid it here, added the column here. So out of the 13,095, 11, almost 12% were subcompact, etc. So here's your relative frequency table, and here's your frequency table. Okay, another example. In an effort to reduce the number of gun-related homicides, some cities have run buyback programs in which the police offer cash to anyone who turns in an operating handgun. Chance Magazine looked at the results from a 4-year period in Milwaukee. The table below shows the types of guns turned in and the types of guns that were used in homicides. So here's the gun types, here's the distribution on the buyback program, and here's the distribution of guns used in homicides. Write a few sentences to describe the two distributions. So it's important as we work through this course that you learn to interpret data and then be able to write conclusions or descriptions in context. So it says more than 76% of the buyback guns were small caliber, but this gun type was only used in about 20% of the homicides. Most homicides utilized the medium caliber guns, yet these represented less than 20% of those collected. So interesting difference in the distribution between the buyback and the actual homicide use of guns. Okay, so now I'm going to move on to Chapter 3. So Chapter 2 was categorical data. Now we're going to move on to quantitative data, numerical data, and we're going to learn about a lot of different displays in here. So histograms, okay, when we do a histogram, we divide the data up into bins. And it helps us to, it's similar to what we did on the categorical data, but here the bins are going to have numerical boundaries on them rather than categories. And so when we do that, that's going to allow us to create a display called a histogram. Okay, so in StatCrunch, I'm going to use the textbook data set from Chapter 3 on sugar in cereals. And again, I'm not going to share the screen because I seem to be having a little issue on the my StatLab program. So let's stay over here. I've got screenshots. So you pick Graph, Histogram, and select the variable sugar percent. and then do relative frequency or frequency. So here's what the window looks like when you're building the display. And notice you can also select a group by a selected variable if you wanted to, and then here's where you pick frequency or relative frequency. You can also adjust where your bins start and the width of your bin too. And you're going to take the same steps when you're working on a dot plot, a stem and leaf, or a box plot. So you're going to have the same choices here in the window where you create the display. So here's a histogram of the sugar in the cereals. So what can we say about this? What percent of cereals have more than 30% sugar? So more than 30% would mean that we would go here and we would count up the frequencies. And it comes out to be, if you count it up, about 41%. So again, we can do summary statistics, use the sugar and cereals data set again, go stat, summary stats on the columns, select the variables. Notice here that all the statistics, I shouldn't say variables, all the statistics are initially selected. You can unselect just by clicking on one of them and then do a control click to select multiples. I'm talking about down here on the statistics. So this should actually say here, select the statistics, not the variables, statistics. And then down here you can pick whatever statistics you want to run, and they'll come up in this window here when you've selected those. Okay, so here's my output for my sugar. There were 49 cereals. Here's a standard deviation. Here's my 5-number summary. I have my min, my max, I have Q1, I have my median, and I have Q3. We're going to talk about 5-number summaries in just a minute. So stem and leaf shows the distribution of a quantitative variable, like histograms do. They contain all the information in the histogram, and they also contain the original data value. So here's an example of the same data, the sugar data, with the stem and leaf. So in this case, the first line here is giving us the sugars that are between, the first two are between 0 and 10. So we have some with 1%, 2%, 5%. Then we have one with 11%, 15%, 20, 21, 22, etc. Notice here you could recreate the whole data set because you have the individual data values listed. So now I can ask that same question, what percent of cereals have more than 30% sugar? So I could add up actually here, 1, 2, 3, etc. And when you do that, you come out with 20 over 49, which is about 41%, which is what we guesstimated off the histogram. Here's a comparison. This has got heart rates for women, pulses rather, and then the stem and leaf that goes with it. So again, if you were to flip this down and orient it the same way, you'd actually see the same picture here, because if you notice, there's a single observation here, and then we have a peak here, which corresponds to this line of the stem and leaf. So actually, have the same shape. And here's a dot plot. A dot plot shows one dot. The difference here is there's no groupings. If you go back to the stem and leaf for a minute, if you notice here, we do some grouping like we do on a histogram. On a stem and leaf, we basically have a number line, and we put a dot on the number line where the data values fall. And if you notice here, this is a nice bimodal distribution. We see two groupings. And this can be displayed vertically or horizontally. It's called a dot plot. Again, you could write down all the original data from the dot plot. And here's the cereal data again. I did a dot plot in StatCrunch. So what do you see? You see two groupings, again, just like we saw on the histogram. So let's talk about measures of center. This chapter covers quite a bit. Measures of center. We're going to talk about the median, which is the value with exactly half the data values below and half the data values above. The mean, and we use X bar for the sample, and we use the Greek letter mu for the population parameter. We also have a mode, which is the most frequent, and this is the only measure of center that we can use for categorical data. Interquartile range. The quartiles divide the data into 4 equal sections. 1/4 of the data lies below the first quartile, 1/4 of the data lies above the third quartile. And the difference between Q1 and Q3 is called the interquartile range, IQR. Contains the middle 50% of the data values. So we did measures of center. Now we're going to talk about measures of spread. The range, max minus the min. The standard deviation. And we use the Greek letter, we use S for the sample and the Greek letter sigma for the population parameter. The interquartile range is another measure of variation. So when we're describing a distribution of quantitative data, we want to make sure we always talk about the shape, the center, and the spread. The shape, this is talking about the humps, and these are called the modes, the peaks. One main peak is called unimodal, 2 peaks is bimodal, and 3 or more is called multimodal. So here's some nice examples. Here's a nice unimodal histogram. Here's a bimodal. Here's a multimodal, a lot of peaks. And this is what we call uniform. It's basically flat. There's really no highs or lows. Uniform distribution. Is the histogram symmetric? If you were to fold down the middle, down the modal category, are the 2 halves approximately the same? If so, we say it's symmetric. It's not going to be perfect, but this is a nice and symmetric distribution. If you go back and look at this one, this is also nice and symmetric. So it may not be symmetric. It may be what we call skewed, where it has a long tail on one side. So this one here is called skewed left, skewed right. Unusual features. You want to talk about whether you see outliers, whether you see gaps in the data. Okay, the 5-number summary is a nice way to summarize your data, and it uses the min, the max, the median, the quartiles, and the extremes. And in StatCrunch, I showed you an example before in the serial data. Remember, we had the 5-number summary. So here's the minimum, here's Q1, here's the median, here's Q3, and here's the maximum. So when you're going to talk about a distribution of quantitative data, you want to report the shape, you want to talk about the center and the spread. So if the data is skewed, you're going to report the median and the IQR. If the data is symmetric, you want to report the mean and the standard deviation, and you may also report the median and the IQR. Also talk about the gaps and the outliers. So you want to describe the modality, you want to talk about the spread, any skewness, and then if you're going to report summary data, this is what you'll do. Summary statistics, median and IQR if your shape is skewed, mean and standard deviation if it's symmetric. So we can use that 5-number summary to make a box plot. And these are particularly effective to compare groups. So you're going to create fences by subtracting 1.5 times the IQR from Q1 and adding 1.5 times the IQR to Q3. And these are called your fences. If any data values lie outside of these, they're labeled as outliers. Draw the box. The bottom bar is Q1, top bar is Q3. The median is shown within the box as a line. And then if there's outliers, you're going to show the fence on the box plot and the outlier as a circle beyond the fence. If there are no outliers, then the whisker is going to go out to the min and or the max. So here's an example from your book. This is a really nice example because they give you the histogram and they also give you the box plot. If you notice on the histogram, it's unimodal, but it's extremely skewed here to the right side. And we expect here we have a big gap and we maybe have some outliers. When we created our box plot and looked at our upper fence, we actually found out there were several outliers that we might not have really been able to characterize on the histogram. This one certainly is, but we may not have known that these were actually categorized as outliers. So what can you see on the histogram that you can't see on the box plot? On the histogram, you can see the mode, the modality. You can't see that on the box plot. You can see skewness on both. Notice the distance from the median to the max. You can see that skewness if you compare that distance to the distance from the median to the min. What can you see on the box plot but not on the histogram? You can actually see outliers identified using a criteria. So it's helpful actually to do both displays. So again, in StatCrunch, you're going to go to Graph Box Plot, select the variable, and make sure you check the box for Use the Fences to identify the outliers. So here's the box plot on the sugar in cereals. What does it tell you? You can't, now notice again, you can't see that this is bimodal on the box plot. You can see it on the histogram though, so that's why it's important to do both displays. Okay, here's a couple of questions. This histogram is supposed to be, again, the sugar in the cereals and describe it. Again, we talked about it. This is a definitely bimodal distribution. Let's just look at the left cluster now. Is this symmetric or skewed? This is actually fairly symmetric. Again, I mentioned it's not going to be perfect, but it's fairly symmetric. And then how about the right cluster? This cluster is going to be skewed to the right. What's the reason for the shape of the histogram? So now here's where you have to think about the data and the information that you've collected. So we're looking at the percent of sugar in cereals. Now, if we think about it, there's two distinct groupings here, and it might be that there are different kinds of cereal. When we see a bimodal histogram, we tend to think that perhaps the data was drawn from two different populations. And in this case, the most appropriate answer here is that there's cereal marketed to kids, high sugar, and those marketed to adults, the low sugar. So again, we actually took samples from different distributions, from different populations. All right. Here are some annual numbers of deaths from tornadoes in the United States from 1990 through 2000. And let's do some of the statistics by hand. So I just wanted to give you a little practice. So for the mean, what are we going to do? We're going to add up all the data values and divide by the number of observations, and I got 56.3. If I'm going to do the median and quartiles by hand, I need to put the data in order. So I went ahead and I rearranged it from lowest to highest. So I've got 3, 6, 9, 10. I've got 11 data values. So the median is going to be right in the middle, the 6th data value. Now to find the quartile 1, I'm going to find the median on the lower half, and I'm going to include this in the lower half because it's one of the data values. So the median is actually going to fall, Q1 is going to fall between 3 and 4. In this case, 36. And over here, it's going to fall between 67 and 68. And so your range now is going to be 130 minus 25, or 105. And your interquartile range is going to be 68 minus 36, or 32. Okay, small warehouse employs a supervisor at $1,200 per week, an inventory manager at $700 per week, and 6 stock people at $400 per week, 4 drivers at $500 per week. What is the mean wage? I would go ahead and write the wages out here. So we have 1 supervisor at $1,200, 1 inventory manager at $700, 6 stock people at $400, 1, 2, 3, 4, 5, 6, and 4 people at $500. And now I can find the mean. And it comes out to be $525 per week. Now they want us to find the median. So I'm going to put the wages in order. 6 400s, 4 500s, 700, and 1200. I've got 12 this time. So where's my median going to be? It's going to be the average of the middle 2, which is 450. Now remember, the mean was 525. The median is 450. And let's do one more while we're here. What would be the mode? The mode would be 400 because that's the most common in the data set. Okay, this one here. The stem and leaf shows the population of the 50 states in millions of people according to the 2010 census. What measures of center and spread are most appropriate for these data? Explain your answer. Okay, so what do we notice here? It's definitely skewed, and a skew to the high side. So if we were going to use a measure of center and variation, we're going to go with the median and the IQR because the data is skewed to the right, skewed to the higher values. The 5-number summary below was calculated from fuel economy ratings for 67 model year 2012 car subcompact. Are there any outliers? All right, so you've got the 5-number summary. The only way to know if there are outliers is go ahead and calculate the fences. So I need the IQR. 25 minus 20 is 5. And then I'm going to find 1.5 times that, which is 7.5. Now I'm going to subtract that from 20. To find out if there's any outlier on the low side. I'm going to add it to 25 to see if there's an outlier on the high side. Low side, I get 12.5. My minimum is 15, so I don't have an outlier there. The upper fence is going to be 25 plus a 7.5, 32.5, and I have a maximum of 112. So I have at least one outlier. So there's at least one outlier. The maximum is beyond 1.5 times the IQR, so there's at least one on the maximum side. A veterinarian was interested in tracking the lifespan of his clients. He compiled information on breed, gender, birth date, weight, and vaccination dates. Which graphical display would not be appropriate to display weight? Okay, so weight is quantitative. So let's take a look. We can use a box plot. We can use a dot plot. We can use a stem and leaf, we can use a histogram, but we can't use a pie chart because this is quantitative data. We're talking about weight. If we were talking about gender, we could use a pie chart, but when we're talking about a quantitative variable, pie chart would not be appropriate. Okay, that's the material for today. Unfortunately, we didn't have any students participating, but hopefully by watching this video, it will help you with your lessons this week.